Today I am going to explain the difference of cross compilation from that of remote compilation. We have here a small C++ code, and we're going to first natively compile this. So to do that, let us check the native CPU where this machine is running now, and it's an Intel x86-64. So to compile the source code, I will have to use its native compiler, which is G++, and I can compile the source code like this. And it will produce a binary of same CPU type of that of x86-64. And we can check the CPU type of a binary via the file type. And we can see that this file is of x86-64 format. Therefore, I can run this code without problem. But sometimes there's a need to compile the C++ code to produce an executable of different format, which is no longer an Intel x86-64. For example, the format of CPUs in our cell phones are not x86-64. Most of them are in the ARM64 CPU. I have here running Jetson Nano, which runs on ARM64. Raspberry Pi 3 and 4 also are on ARM64. So let me open a new terminal and I will log in into that Jetson Nano that I have here running. And the CPU is ARM64. I can also verify a second time using uname command, and it tells me that it's ARM64. So to build this main.cpp into an executable that is compatible to a target destination machine where the executable is to be executed, I have to use a cross compiler. In my machine here, I have that cross compiler which I downloaded from Linaro, and that cross compiler is, I unzip it over here. So this GCC Linaro came in as a zip file, and I unzipped it. I just have to be careful with choosing the correct zip file, because there is a zip file for Windows, for Mac, and other platform. Since I have here an x86-64 Linux, so I have to choose the correct zip file to use. I unzipped this, and it exploded into these contents here. And inside the bin folder is the cross compiler. So the cross compiler will execute in our machine now, but its output, the output that it will produce will be of the ARM64 type. So I will compile this time again the main.cpp, and let me delete this old output here, and let me compile now using the cross compiler. So we specified here the full path of the C++ compiler, and then I tell it compile the main.cpp. And now we have a.out executable, and if I try to run this, I will not be able to run it. It says format error, and if I check the type, it will say that its type is ARM64. But if I copy this output binary to the Jetson Nano, and then I'm going over here to where I log in into the Jetson board, and I can run the executable, and it runs fine. There's no error. Yeah. So argc is 1, and that's why it's returning 1. So let me verify that again. And it's returning 4. All right, so I'm just double checking because usually the $? In the Unix convention is to tell us the status of the last program that executed and finished. And usually the convention is 0 when there's no problem, and 1 if something is wrong, 2 things are wrong, 3 things are wrong. So if 0, then nothing is wrong. And as you see here, 1 is returned in the status. But it so happened that the C++ code that we have here is written in that manner, so that is fine. Okay, so this step here, this one line here, would be what you call as cross compilation. So the process of cross compilation is first acquire the cross compiler and set it up in your development machine. Here I am lucky because the ARM64 cross compiler comes in as a zip file, so I just have to download it and unzip. In other new CPUs, it might not be as easy as that, but the principle is the same. The first step is to acquire the cross compiler and set it up in your development machine. Now, let's go to the next topic of remote compilation. I will launch Visual Studio 2019 now, and I will create a new project, and I will select a C++ empty project. But here, I will specifically select a Linux type. So in this drop-down, you will see several types of options, and Linux will appear here as one of the options if you check the Linux development C++ during your installation of Visual Studio. In case you haven't checked that, you can rerun the installer of Visual Studio and check the Linux development C++. It's only less than a gigabyte of additional storage, so it doesn't hurt to always add this option. And then I will select empty project on a console. Next. I will add the main.cpp source code. I will type the small C++ code here. You will notice in this project that there's an IP address here that the ID is connected. And if we verify the IP address of Ubuntu, so there it's connected. But in case it's not here and this is your first time using this, go to Tools, Options, and then in the cross-platform, you'll see here an Add button, and you'll click that and you'll specify the IP address of your Linux remote system, your username and password, specifically your SSH username and password. So I already have it here. So now I'll do a build. So what's going to happen here is it is going to utilize everything in this Ubuntu, including most importantly, the compiler, the GCC compiler, to build this source code here. In fact, in addition to that, it also copies the compiled executable into the Ubuntu after that. So if I build this, and it succeeded, and it's using the compiler here, the GCC, and it rolls everything under the home folder, projects, and then since this is project 9, there should be a project 9 folder here. Okay, and then the binary would be here, and this should be the executable. In fact, it also copied the same source code over here. Then I can also debug this by putting a breakpoint here and press F5 to debug it. And while we are at the breakpoint, we can go over here into our Linux environment and check that project 9 is currently running because it's being debugged. Okay. In addition, just so you will understand how useful this is, I can even create a header file in my temp directory. So I will just do that now. VI, and I will put it into the temp directory and some header .h, and I will define a preprocessor, some var, and a value like that, save, and then I can include this some header file in my Visual Studio Code here, like that. But I have to tell in the property configuration where to find it, since all of these are to be taken under the context of the remote Linux machine where it is connected. So this include directory here and specify tmp, and then this some header file will be searched into from the tmp location, and then I can use the variable here, what was that? Some var, do a build, and then if we do a test run, and we can see the message here. So stop the debugging. So now that we understand a little bit more on what remote compilation is, so it is a type of compilation that does not need any setup works to be done in the development machine. All that needs to be done is specify the IP address and username to the remote machine where you are going to be doing the development. So while this is in my Windows computer, this Visual Studio is running in my Windows, but the build and the debugging and the configuration in the properties like adding header files, libraries are to be taken at the context that it is to be in the remote machine where this IP address is pointed to. In fact, I can change this IP address to my ARM64 here, and it can switch to my ARM64 development right away. So let us try to do that. Maybe I can do the selection here in the tools, options, and select the ARM. Now it's connected to 136. And a connection can be added in the tools. Let's see. Okay, it's here. Build. Okay, it's not yet connected. Somewhere is sometimes it's not. Okay, so now they're connected. And then if I build this, and you can see that it could not find the sum header.h because it only is in the Ubuntu machine. But if I copy this to the other machine, so it's now here in my Jetson board. So I'll do the rebuild. So it's not finding it yet because we're going to do to the projects and specify the include directories. So somehow when we switch to the platform, it also erases the configuration where to find the header file. So update that to TMP and rebuild, and everything should work now. Okay, there. I can also debug this, and while it's still debugging there, so it's not anymore in the Ubuntu, okay, but instead here into the Jetson board, in the Raspberry Pi or whatever. Now it is switched to running here. So this is what is remote compilation. It is best exemplified here in Visual Studio, where the Visual Studio IDE configured the IP address, username, password in the SSH connection protocol to use everything in the remote from the compiler and from the file system. So what just you need to do is have a cozy feeling of IDE power in Windows, but the actual development actually is happening in the remote machine. So this scenario is most practical when the remote machine is very powerful, like a supercomputer or cloud, and you can use it like this. But if the remote machine is a single board computer like a Raspberry Pi or just a Nano, then you would prefer to choose cross compilation instead. So thank you guys, and I hope you learned something. And now it's a little bit more, we shed the light on the difference between cross